Okay, so we're recording again. I'm just gonna resit like a human. You know what? I am gonna name it Spicy Questions just because you said that, and I love it. No, you don't want to know. Sorry, that was my sister. Alrighty, guys. So let's get started. First we're gonna get that wasn't English. First, we're going to do naming problems. So we have an alcohol and we have a chlorine, and they are ortho to one another. I'm going to write this over here just for reference. So if we have some substituent here, let's call it X, or you know what, let's call it A. If we have any substituent right next to it will be ortho, and then it will be meta, and then it will be para. And then someone said, is this chapter 16 practice problems? In our set, it was under 14, so we just left it that way. But yeah, so this is considered chapter 14. So, these two are ortho to one another, so we're going to cross out meta, and I'll do that in red. We're going to cross out meta, we're going to cross out para, and we're going to cross out this because why wouldn't we use that naming, right? So now we're down to 50-50 because those two are the only ortho options available. And then we are just going to look chlorophenol. That sounds pretty good. Chlorobenzyl alcohol. What do you guys think? Ooh, we kind of have a split, but most people said B, and you would be correct because remember, if we had a benzyl alcohol, it would look like this. It would have an extra carbon there. So you guys are correct. This is O, chlorophenol. So this second one, now they are meta to one another. So we're going to take out any answer choice that's not meta. Wow! We got rid of all the answer choices. Yay! And yes, this is really how they will be on the exam. So if you guys want a screenshot, go ahead. I'll give you guys like 2 seconds. And we're going to go here. All right, so now these are para to one another because they're across the benzene ring. You can think about it as like they're on opposite poles. Para poles. That's how I think about it. So let's get rid of everything that's not para. And now we're between nitroanisole and nitrotoluene. So we know this is the nitro. And OCH3 is going to be anisole. Remember, toluene is just methylbenzene. And someone said they couldn't take a picture, so I'll zoom out all the way so you guys can take a picture of this page. Someone said sorry. Don't be sorry. I don't know what you did, but don't be sorry. Okay, page 1, done. Yay. Moving on to page 2, we're going to do one more naming one like this. So they are ortho. Bam, bam. This doesn't even have anything. Ta-da! That's all. It's that easy. There's only one where they're ortho. So that's it. Someone said, are we doing all 53 pages? No, I put a lot of examples here that are very similar to one another, just in case you guys had issues. So, like, for example, I think there's like 10 different naming questions. We're not going to go through all 10 if you guys do like 7 of them or like 5 of them and you're like, oh, this is easy, you know? But we're going to go through most of them. It shouldn't take that long, though. Alrighty. So this one is styled a little bit differently, but it's essentially the same question. Which one is not 2-bromo-5-nitrobenzoic acid? And I like to draw it out for myself first. So benzoic acid is the, what do you call it when it's at the end? Whatever, it's the ending. So we're going to put that on there first, and I'm just going to choose to put it here just because I said so. Right? And we have, in comparison to the benzoic acid, 2-bromo, so 1, 2-bromo, and 5-nitro. So 1, 2, 3, 4, 5 nitro. So we're looking for something that looks sort of kind of like this, right? We know it's definitely not this guy because what the heck, why are they all in one corner? No. We know that it's not this guy. Just kidding, wait, hold on. We know that it is this guy because this is pretty much exactly what we drew here. So this can work. We know that this is the same. We can also see that this is the same, and this is the same. Right? Because they're all pretty much the exact same drawing, just oriented slightly differently. So we know that the answer will be D.
Guys, a lot of people are asking where we're getting these questions from. This is from Rosemary and I's problem sets that we are unfortunately not allowed to give out to you guys. So we pulled from like 700 pages, a bunch of questions for you guys, but we cannot give you access to this. That's why we're giving you time to screenshot it, and it will be in the YouTube recording. So just a little heads up.
Yeah, I've seen this question before. I don't know if it's like, it's probably in the problem set, but this question's in the problem set, I think. Because I've seen it before.
Okay, a couple of them are, but not all of them. Yeah. Okay. So I'm going to say, let's do like one more naming one and then we can move on. So toluene, we went over this. It would be methylbenzene. That simple. I know ethyl can kind of get confusing because they're both R groups. Don't think too much into it. We know that toluene is methyl. And don't get fooled by the methoxy. We know that this would be an ether, not toluene. So I'll zoom out one more time so you guys can see this page. And then let's zoom. I lied. Let's just finish this up because I know people are going to ask me about it. Okay, so anisole is what? You guys tell me real quick. And someone said, can I show you guys the questions that we skip? Yes, I will show it to you guys, and then I will just say we're skipping these ones so that if you guys rewatch the recording, you'll be able to have access to it. So you guys are correct. Anisole is methoxybenzene. And we know that phenol is a hydroxybenzene. And we know that aniline is which one? Yes, it is B. And I know in the set that I gave you guys, I said benzylamine. We can also name it aminobenzene, so just be aware. So xylene is the fun one that you guys might not have seen because it's not really one of the common ones that we talk about. So I will show you guys what it is, but first let's just go through and use common sense, right? If you see something you don't know, think about what you do know. Hydroxybenzene, no, we know that's phenol. Aminobenzene, no, we know that's aniline. Dimethylbenzene, what the heck is that? We've never talked about it. Ethylbenzene, okay, we haven't really talked about that one either. Methoxybenzene, no, we know that is anisole. So right now, you're down to 50-50. And xylene is actually going to be dimethylbenzene. So I'm going to draw them meta to one another. But they can be in any orientation. Just have to have 2 methyls on a benzene ring. And it will be called xylene. I feel like I said that super fast, but you guys can go ahead, screenshot. We're pretty much done with naming. I think there's one more question. And someone said, can we see the last ones? And then someone pointed out, Dr. West apparently said xylene is always meta. I thought it was in any orientation, but I guess it's just meta. If that's what he said, definitely go with that. And I'll just scroll up really quick so you can take a screenshot of these. But I'm just gonna, just for time's sake, I will give you guys like 20 seconds at the end of each set, but I'm not gonna keep going back up just because when you guys go back in the recording, you guys can see it, and I just don't want to spend like way too much time on it. So I apologize, but for time's sake, we're gonna do that. So the next two are also naming, but this is when we get kind of more complicated because there's a third substituent. So I'm going to do the first one, and then you guys can practice the second one on your own. So the first one, we have 3 substituents, and 2 of them are bromine. And we know that this will have the priority. So we know that whatever it is will be something aniline, and the numbers are going to be in comparison to, or in reference to, our NH2 group. So if we count this as 1, it will be 1, 2, 3, 4, 5, 6. So we're looking for 2,5-dibromoaniline. And as most of you guys said, that would be answer choice C. And someone said, why is NH2 priority? And that's just because it's a bigger group, and it also has to do with oxidation states, I believe. It's just one of those IUPAC rules.
Rose, somebody asked if we could do the hard mechanism questions first, since it is getting late.
That's valid.
I just don't know how we would do it.
Yeah. Honestly, I think it's just better for everyone if we just go in order, because you guys can go back and watch it, and I don't want to confuse the people now and the people who will be watching it later. So I'm going to say let's just go in order, and if you guys have to go, I totally understand. Just watch it back later. I'm sorry for the inconvenience. I really am. I feel really guilty, but I think that's just the best way to go. So the answer to 13 is going to be 3, and you guys can just work it out on your own because we've done a bunch of similar questions. Same thing with 14, and I believe also 15. So here, I'll give you guys a chance to screenshot on your own without the answer. And then the answers for 14 and 15 will be B and C. So this is one of those ones that you guys should just practice on your own, extra practice. And someone said, how much longer do you think the session will be? I'm hoping it won't be more than another half hour. I'm really, really hoping. And this is another one that you guys should just practice on your own, so I'll leave it up for a couple more seconds, and then we'll move on. Alrighty, So this is one of those questions. Here, you guys can take a screenshot while I clap to get your attention. This is one of those questions that is really important that you read carefully. So we have why did I cross it out? I meant to highlight. In theory. This is one of those theoretical questions we talked about. And so he's saying, in theory, which of these compounds will rotate plane polarized light? So please remind me, what does it mean to rotate plane polarized light? Chiral, exactly. So this just means chiral. And we're going to draw these out. Okay, so we have benzene. 1, 2, 3, 4. We have butyl benzene. And we know that this is not going to be chiral because it's, not different on either side. It's symmetrical. And someone asked, will this really be on the exam? Not really. I've only seen it like one time, but I'm just including it here because I have seen it once or twice. So I'm just giving it to you guys. So the reason the answer is actually going to be sec-butyl is because A, B, and D, when you draw them out, I will let you guys draw them out, but they will not be different on either side. It'll still be symmetrical. And for chirality, you are looking for something that is asymmetrical. So if you work it out, you will see that sec-butyl will look like so. Ugly. And so in this case, we will be chiral because we will have two separate groups. So this is just a review from Orgo 1. This is not like a huge priority question, but I have seen it pop up before and people got mad at me for not mentioning it. And chiral just means that we have 4 different groups attached to 1 carbon. Another one of those theoretically questions. So we're looking at dichlorobenzene, and we're saying which of these dichlorobenzenes might theoretically yield 3 products, 3 mononitro products. So essentially what they're saying is draw out ortho, meta, and para dibromobenzenes. So we get these 3. This is ortho, this is meta, this is para. So in this case, it's asking theoretically which one can have 3 products, right? So these 2 are equal directing groups, and they are both ortho-para deactivators. So this one will direct ortho and para. This one will direct ortho and para. So this is not correct because theoretically you could have 4 products. So not correct. For the meta one, this bromine will direct ortho-para. This bromine will direct ortho-para. So we have the same answers. That's 3 right now. Cool. The para one will direct ortho, para, and again, ortho, para. So once again, we have 4 possible products, so that is not correct. The reason the word theoretically is important is because we are never going to substitute this position, this one right here, because it's too sterically hindered. It's in between two substituents, so we're never actually going to substitute that, but theoretically, there are 3 positions that we can substitute, so this is our answer. The next one is pretty much the same question, so I will let you guys do it. Do it on your own. I'm sorry, I'm trying to speak too fast. This one is very similar, so I will let you guys do it on your own, like drawing it out and everything. The only difference is this does not say theoretically, so now we're saying which one would be the only one that actually has one product, and the answer is going to be C. So please draw it out on your own and practice it, but it's essentially the same thing, concept-wise. So please feel free to take a screenshot. I saw a lot of questions in the chat about like what these practice problems are and stuff. Just know they are very similar to your practice problems. There's just more of them. Alrighty, so which of the following is the best representation for naphthalene? And this is naphthalene. So the answer is, or I'm so sorry. I tricked myself. You guys have to watch out for the double bonds to make sure they're in the right place. So for this example, it would still be A, but the reason the other ones are wrong is because, one, these have bridges. Naphthalene does not have a bridge, so ew. And then when you look at these more closely, you will just see that the one that is closest to the actual naphthalene molecule is A, and you can also tell that it's not going to be 2 or 3 because that is exactly the same molecule, just flipped around. Alrighty. So for 34 and 35, I'll zoom out so you guys can take a picture. These are exactly the same.
I just realized.
Yeah.
Sorry. Those are literally the same ones that we just did, 26 and 27.
I was going to say. So
yeah, they're repeats.
I'm not going to do it again. They're just repeats. That was our bad. So just practice them. The answers were above, so I'm not going to spend time on that. Okay, so 45 is, here, you guys can screenshot it. 45 is one of those that's pretty much always on the exam. And I included it here because people tend to kind of sort of get confused. So why would 1,3-cyclohexadiene readily undergo dehydrogenation? And for you guys to answer that, I will draw this out for you. So the reason this would undergo dehydrogenation is so that we can form what? What do you guys think? Benzene, exactly. So if we undergo dehydrogenation, we will form benzene. And this is favorable because it would gain stability by becoming aromatic. So that is the answer. All right, I included a bajillion MO theory practice problems. We're only going to do like 3 or 4 of them, and then I'll just give you the answer for the rest. So, consider the molecular orbital theory of benzene. In the ground state, how many molecular orbitals are filled with electrons? So you guys tell me. 3, exactly. Perfect. In the MO theory of benzene, how many pi electrons are delocalized about the ring? So all this is saying is how many pi electrons are there in conjugation. And you guys are all correct, all 6 of them. Yes, exactly. So I'll give you a moment to screenshot. All right, so here, I'll zoom out. So in the MO theory of benzene, how many pi electrons are bonding? How many of them were in bonding orbitals, guys? What do you think? This is kind of a trick question because all of them in the ground state are in bonding orbitals. So the answer would be A6. So these are the kind of MO theory questions he's going to ask. I'll give you guys a second to screenshot, and then I'll go on to the next page. So someone asked a great question, how do you know it was ground state? If he doesn't specify, assume it's in the ground state. You're very welcome. Okay, so next page. So for 57, that is going to be A. For 58, we are going to say pi bonding molecular orbitals. What do you guys think? Now we're not talking about electrons, we're talking about orbitals. Exactly, 3. Perfect. The next one is very similar. So anti-bonding, we know there's also 3. And if I zoom out a little bit, how many degenerate orbitals are there? Yes, so there is going to be, okay, so one thing I wanted to point out, when I was looking at the answer key to this, I saw that it said the correct answer was 2. And as I've talked about in my SI sessions, there would be 2 pairs of degenerate orbitals and 4 actual orbitals. So I was a little bit confused about why the naming this was this way, and I wanted to ask Dr. West about it. But if you guys just have to memorize it at this point, just say that there's 2. If I get an answer from Dr. West, like a better answer, I will let you guys know. Oh wait, I'm just an idiot. Never mind. I literally can't read. I've read this like 8 times. How many pairs of orbitals? Yes, there's 2. So forget what I just said. That was so embarrassing. Okay. So I hope you guys have screenshotted, and I'm just going to go on to the next page. Someone said you're doing great, sweetie. Thank you. All right, so for these ones, it's a bunch of the same thing. So I'm just going to give you guys the answers, and I'll give you a second to screenshot.
Sorry, I probably already asked this, but how many questions are there again?
A bunch. I think there's like about 100-ish.
Oh, okay.
But I didn't count, so I'm not 100% sure. We already did 61. I think that's just a repeat. So from here.
It's not.
Oh, it's not? Am I really just stupid?
It's talking about pi bonding, not just molecular orbitals.
Oh, okay. That's why you guys should read the question.
I can't tell you how many times I've gotten molecular orbital theory wrong just because I don't read.
Same.
I skim.
Also, I'm running on like 2 hours of sleep, guys, and so, yeah. If I start sounding like I'm dead or there's nothing happening in my brain, that's why. I'm trying my best to stay focused. Okay, so these are the answers to these ones. Please screenshot, and if you have any questions, just email me, but these are pretty straightforward from the diagram. So we're going to go through it kind of fast. So these are more of the same. Feel free to screenshot for practice before I fill in the answers. '71 we'll actually just do together because we changed it to cyclobutadiene from benzene. So how many antibonding orbitals did we have for cyclobutadiene? Awesome. A couple people said it. Yes. So there would be 1 antibonding, and we know that there would also be 1 bonding and 2 non-bonding. And we know that we would have 1 pair of 1 pair of degenerate orbitals. And then we also know that if we asked how many pairs of bonding orbitals we have, we know that the answer is 0 because those would be non-bonding orbitals. And for 74, they ask the same thing except replace it with antibonding. And again, we know that the answer is 0. So I'll give you a second to screenshot. There we go. All right, so the last MO theory one, 75, we'll do together. So in cyclobutadiene, how many non-bonding orbitals are there? We already talked about this one, but I want a little bit more participation. So yes, there are going to be 2 non-bonding orbitals. Awesome. Okay, so we're finally done with MO theory. All right, so this is the question that I keep telling you guys about because I know it's going to show up on there, and I want you guys to be prepared. So which of the following is not true of benzene? And if you guys read them all, I'm not going to read them all out loud to you. But we know that the carbon-carbon bonds are not going to alternate. All of these will be exactly the same length. So that is not true. This next one is saying which of the following is true. And so if you read all of the choices, you will be able to tell that B is correct. All of the hydrogens are going to be equivalent. And 85 goes along with the answer to 83. So all of the carbon-carbon bonds in benzene are of equal, I'm on the eraser, are of equal length. And it is intermediate between a double bond and a single bond. So please know these 3. Usually at least some variation of one of these 3 will show up on the exam. Okay, moving on. So I'll give you guys a second. And this is more of the same. So we're going to go through it kind of quick. So this is talking about the 2 resonance structures. And this is another one that I stressed before in SI. So the correct answer is D. Neither of them are equivalent. The correct, or the most correct structure for benzene is going to be the resonance hybrid. For 89, which of the following is true regarding the cyclopentadienyl radical? And I will draw that out for you guys. That is this. This molecule is cyclic, planar, fully conjugated, and it has 5 pi electrons. So what do you guys think is the answer to 89? B, exactly. It is not aromatic. Awesome. So the next one is very similar, except it's the carbocation. So now it's cyclic, planar, fully conjugated, and 4 pi electrons. What do you guys think? Ooh, we got some split between A and I think D, people were saying. Or B, actually. Or D. Okay. So it's actually still going to be B, because answer choice B does not say that it is non-aromatic. This is going to be anti-aromatic. So the most correct answer choice is B. This is one of those ones that he tries to trick you with on the exam. So you guys will read this, and usually people will think, oh, non-aromatic, so this doesn't make any sense. Just keep in mind, anti-aromatic is technically not aromatic. And 95 is the question we talked about earlier. So it's saying that Huckel's rules, that's basically just the rules for aromaticity. And we know that it does not have to be monocyclic. So B is the correct answer. It does not have to be monocyclic. And Katrina just said that's roughly 150 questions, and when I tell you, I almost started crying. Okay. It's cool. We're getting through it. We got this.
Rose, whenever you want to switch off, we can if you want.
That's so valid. Okay, so I actually have to leave at 7:30. So how about I just go until 7:30 and then we switch off?
Oh crap, I kinda gotta go too.
It's fine. We'll figure it out. It's fine. We'll just go through it really fast. Okay, so these should be super fast because we've done almost all of these in SI. So we're just going to go through them super, super quick. So which one is aromatic? E. Awesome. So which one will be aromatic in this case? Well, we already know it's not that, it's not that, it's not that, and it's not that. So what do you guys think? It's E again. Awesome. So, okay. We'll give you a second and we'll move on to the next page.
Oh, quick question. What does the 2 plus mean?
Oh, that's a great question. So it's just saying that it looks like this.
All right, thanks.
You're welcome. Someone said these are from the weeklies. Oh, that's cool. Okay. So these next two, this one is saying which one will be aromatic. We know that it can't be this one because it's sp3. We know that this is aromatic. And we know that if this cation is aromatic, neither of these can possibly be aromatic. So the correct answer is B. The next one is also asking for aromatic. Again, sp3, so it cannot be. This one we're going to treat as a cation, anion, and radical, and it's essentially the same exact one as 98. And the answer will again be number 2. Alrighty. So again, which one would you expect to be aromatic? That's the same for both of these questions. So what do you guys think for 100? You guys tell me. Okay, awesome. People said A. Really glad. So this is sp3, sp3, sp3. So all of these are non-aromatic, so they are all wrong. The only possible answer choice is A. Same idea for number 2. This one and this one are sp3, so it's automatically non-aromatic. And then we're comparing essentially the cation to the anion. This one has 4 pi electrons, this one has 2 pi electrons, so we know the aromatic option will be A. This next one is pretty much the same, so 102 will be A again. You can work it out. All right, so for number 103, just know that these things written here, like K and Br, those are just spectator ions that are there to confuse you. So just kind of ignore them. Cross them out, whatever helps you. They're just spectators. So I want you guys to work this out on your own. But if you look at the examples we've done already, you've probably worked out all of these already, and you know that the answer will be B. And the reason is we have 10 pi electrons here, and that would mean that this will choose to be planar and it will choose to be aromatic. I'll zoom out for a moment, and then we will go to the next page. Katrina, do you want to finish up aromaticity, and then we can switch back whenever?
Yeah, that's fine.
Okay, cool. And thank you for being so nice and patient with us.
Yeah, thank you guys. We pulled so many. I'm kidding you not when Rosemary paged through 700 pages of practice problems to pull these guys out. It's a lot.
And in my head, I was like, great idea. We'll do 1,000,000 questions. But then now it's taking forever. So I'll let you do your thing now.
Yeah. All right. So we are just asking which one would we expect to be aromatic. So we know that 4 isn't, because if you notice here, this is not going to be sp2 hybridized. Actually, I lied. It is, but the reason why this guy won't be is because we will have 5 pi electrons for this one. This guy here, once again, is sp2 hybridized as well, but notice how we only have 4 pi electrons, so we know that guy is not it. And this guy here is not sp2 hybridized. This guy is simply sp3 hybridized, so that leaves us with 3 as our answer. Okay, and then 105, I will zoom out so you guys can see both of these at the same time. This guy, sp3 hybridized. The rest of them, we are A-okay on hybridization, so then we go in and look at them. This guy here, we are going to have 4 pi electrons. 4 pi. This guy here, we will have 6 pi. And then the last one, we will have 5 pi. So, since this is 6 pi, we know that one's going to be aromatic based on our aromatic numbers. I will let you guys screenshot this page really quick. There's only 2 problems, so it shouldn't take very long. Okay. All right, so now these are talking about the molecular orbital theory and Huckel's rules. Don't really worry about that too much. Basically, you just need to do it based on Huckel's rule and then aromaticity. So it's asking, out of all of these molecules, which one of these are going to be aromatic and which ones are not. So let's pick through them really quick. If we look at the first one, we know it's fully conjugated. Let me zoom in on this. We see that it's fully conjugated, and but it only has 4 pi electrons, meaning this guy is not aromatic. This guy here is a little funky, but I do believe it's going to be sp2 hybridized throughout, and we will have 4 pi electrons as well, meaning that guy is not going to be an answer choice. This guy here is sp3 hybridized, so we know that is not it as well. And then this guy here, we have 6 pi electrons. This guy here, we have 2, 4, 6, 8 pi electrons. If we look over here, fully conjugated, we also have 6 pi electrons. This guy is sp3 hybridized, so that's not one of them. This guy has 2, 4, 6, 8, 10 pi electrons. And this guy here, we do count these lone pairs, so we have 6 pi electrons. So the only ones that are aromatic are going to be 4, 6, 7, and 9. I almost forgot how to count Roman numerals, but that's fine. All right, I will zoom out at the end. Just give me a second. Let me run through these. So careful, this one is talking about anti-aromatic. They literally give you the same exact molecules as before. So as long as you remember those from before, you should be pretty set. This one has 4 pi. Oops, sorry. 4 pi. This one also had 4 pi. And then anything past 6 doesn't matter. I mean, yeah, basically. This is 8 pi electrons. And then this one, we know these are aromatic based on what we learned from before. And then this guy here is sp3 hybridized, so we know that cannot be an anti-aromatic. This one is also sp3 hybridized. So that means 1, 2, and 5 are our answers. So go ahead and take a screenshot of this, guys. I will try and run through these as fast as is humanly possible without losing all you guys. But yeah. Okay, hopefully you guys grabbed a screenshot of that. If not, it will be in the YouTube recording. And now we're asking about non-aromatic. So if we went back, we can cancel all the ones that are. So these are anti-aromatic, AA, AA. This guy is not. So that guy is good. This guy is aromatic. This one is anti-aromatic. This guy here was aromatic. This one here, oh, I crossed that out, my bad. sp3 hybridized. This guy here was aromatic, and this one was also aromatic. So that means our only options are going to be 3 and 8. So that is our answer. Perfect. All right, cool. So now we are talking about which of these compounds should be aromatic. Once again, more aromatic things. There are so many of these practice questions in here. 4 pi, sp3 hybridized. So we know these two are already out. This one has 4 pi as well. So we know that one's out. This one has 3 pi. We don't count that one. And then finally, we are left with 5. And since he doesn't give you a none of the above, this is going to be our answer. And this guy has 6 pi electrons. Okay, guys, so Rosemary and I are going to actually end this session at 7:30, and then we will go through the rest of this packet on our own and put that in the recording as well. But we will do that tomorrow morning. So we'll upload whatever we have tonight, and then tomorrow we will take time and record the rest of them. I'm just going to let you guys screenshot this page, and I will give you guys the answers to it. So go ahead and take a screenshot of that. 110 is going to be this. 112 is going to be this. Yeah, guys, if you have to go, don't worry about it. I know it's been a long, long night, so I'm going to just keep scrolling. It was intense, but...
And then while she scrolls, I just want to say, you guys are doing amazing. We're sorry that this kind of ended up going way long and it was kind of a mess at the end here. Personally, my head has not been in the game. And so yeah, thanks for being so nice. Thanks for being so appreciative. You guys have been amazing. And we will try to get that done for you as soon as possible because I know you guys want to practice for your exam. So if you gotta go, I don't know what I'm saying anymore. I just wanted to tell you guys I'm appreciative of you and how great you are.
Rose, we have a lot more aromatic things to go. Do you want me to just like go through these really quick and then just put the asterisks next to them for the recording, or do you want to just start on this tomorrow?
I think we'll just start on that tomorrow because I think we might be scared of them.
It's all good. All right, yeah, let's just call it a night. All right, guys.
Okay.
We will see you guys after your guys' exam. So, good luck.
Bye.
This was the most intense exam review.
I know. And then someone asked, what about
it's
the ones...
Rose. We only have like... Go ahead.
Oh, sorry. Someone just said, what about 15 and 16? We'll post those tomorrow, going over it. We'll try to do it like in the morning-ish or as soon as possible. It'll be for sure done by the end of the day. But yeah. And then someone said I have a lot of questions. I hope we answered them all.
And if not, you know, our emails are open. So even though tomorrow's technically no school or anything, we will still be looking at our emails.
Yep.
All right, Rose, we only have like 28 pages to cover tomorrow.
I love that.
It was great. It was great, guys.
Thanks, Jared.
I had to go for an hour, for 30 minutes because I picked up my sister, but I was here for most of it.
I cannot
So
believe
shocked.
you stayed for this.
I know.
Yeah,
I saw your name pop up. I was like, oh my God, it's Jared.
All right, I'm gonna go finish my project here, but I'm gonna send the question I have in our group chat though. All right.
Gotcha.
So bye.
Bye.
Bye, Rose.
Bye.
Get some sleep.
You too. Thanks.